Hey everybody, today we are going to work through similarity lesson number 3. Now this is going to sound a little bit like a lesson that we did a few months ago about congruent triangles. When we did congruent triangles, we talked about how do we know that the triangles are going to be congruent, and we talked about things like side, 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 angle, side, angle, side, angle, 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 side, all those things. And some people have some bad memories about them because you end up having to use those in proofs. Other people thought it wasn't all that bad. That's not what we're doing today, but it is going to sound similar to that. Today, instead of trying to figure out whether two triangles are congruent or not, we are going to try to find out if two triangles are similar. Now, when two triangles are similar, that does mean the angles are congruent. So the angles of the triangles are going to be the same. The difference is now the sides do not have to be the same as each other. However, they do have to preserve their ratios. So for instance, if you had a triangle that had a side of 3 and a side of 6, and then another triangle had a side of 4 and a side of 8, those sides would be preserving their ratios because 3 over 6 and 4 over 8 both reduce to the same thing. They are both 1/2. Okay, so we're going to talk about what this looks like with similarity. So here's what we're going to do. We're just going to name this first triangle ABC. When we are trying to write that two triangles are similar to each other, we use the little tilde right there. You see it in Spanish, you see it in various places. In this case, instead of using the congruent symbol, we're just going to say, hey, these two triangles are similar. They're not exactly the same, but they are similar. Now, if you're having trouble figuring out what triangle matches with what other triangle, sometimes you need to do a little trick with your brain. Sometimes you need to actually rotate things. I'm going to do that for you real quick. If you were to pick this thing up, rotate it, there you go. Now you can obviously see they are not the same, but they are similar. Okay, so let's take a look here. Because one is really just sort of a rotated version of the other, you have to sort of say ABC is similar to triangle. And then again, because it's flipped, we have to name it EDC. Okay, that's the only way. Now, how do I know they're actually similar? Well, let's take a look. We have a matching angle right here and a matching angle right here. The rule says if two triangles are similar, it means the angles are congruent to each other. Now, what about the other angles? Well, it turns out this and this are also congruent because they are vertical angles. It goes back to something we did in the very first chapter. So we have two angles that match up. Here's the thing. If two angles match up, then the third is a match as well. I can even prove it to you. We're just going to make up numbers. We're going to say that this is 90 degrees. Obviously, it's a right angle, so it would make sense. And let's just pretend this is 30 degrees. Okay. Now, I'm not telling you it's exactly 30. I'm just doing the example here. Triangles have to add up to 180. So whatever the third number is in this situation, it would have to be something that would make the whole total add up to 180. So 90 plus 30 is 120. That means you would have to have 60 degrees left. Now let's take a look over here at the other one. Well, if this is 30, then doesn't that mean that would have to be 30? And then if we have 90 and 30 again, doesn't that mean the third one would have to be 60? Long story short, if the first two match, the third has to match because that's the only way you could make the total 180. And we know that every triangle adds up to 180 degrees on the inside. So how do we actually name this rule? Well, if two angles match, then the triangles are similar. Well, that's pretty simple. We can call it the Angle-Angle Similarity postulate. I'll give you a second to write that down. Now, if you're wondering why we didn't say AAA, like in the congruent triangles chapter, we always used 3 letters. Again, that goes back to what we just got done talking about. You only need 2, because if 2 of them match, then the third is automatically also a match. So you only really need 2. All right. Now, if you look at this next picture, and again, you can pause this if you don't want me to move forward, but I'm going to move forward. If you look at the second picture, we have triangle STU, S-T-U, and it is going to be similar to triangle X, Y, Z, and I'm going to prove it to you. If you look over here and you look over here, you have 9 and 6. So the ratio of one to the other would just be 9 over 6. Now, if you look over here on the other side, you get a 21 and a 14. Now, from here, there are 2 different ways to look at this. You can either just reduce each one and make sure they reduce to the same number, or one other trick that you could use is to cross multiply and just make sure each one multiplies to the same thing. In this case, 21 times 6 is 126, and 9 times 14 is 126. So there are a couple of different ways that you can test it out, but I will tell you that those have the same ratio. That means these sides are proportional to each other. This triangle has sides that are proportional to the sides in this one. Now, that's not good enough to just have that, but what we also have is a matching angle in between. When you put all that together and you follow along, we have proportional sides here and here with a matching angle in between. So you have 2 S's with an A in the middle. That would be side-angle side similarity. Now this one, if you read the book, it says it's a theorem. You know that is usually not the battle that I face. That's not the battle I fight. Some books probably call it a postulate. Some call it a theorem. What I've read calls it a theorem, so I'm going to go with it, and we'll just go from there. The first one will be a postulate. The last 2 will be theorems. Usually it doesn't really matter because usually we just abbreviate it that way anyway. All right, now, if you look at example number 3, and I can leave example 2 up while we move on, this is yet another example of 2 triangles being sort of flipped versions of each other. So if you look at the big one, it's going to be triangle MLN. And then if you look at the little one is a flipped version, so you have to sort of visualize that, and you have to use FEG. Now, this problem is a little bit different. I don't have any angles to work with at all. So what I have to do instead is just test all 3 sets of sides. So if you look, the biggest side on the big triangle is 10, and the biggest side on the little triangle is 5. So we'll do 10 over 5. And I just want you to make that note on the side of your paper, 10 over 5. Then we go to the next biggest, and we'll do 7 and 3.5. Just make a note. We can't do any cross multiplying because we're going to end up with 3 different ratios. We are going to test 3 different sets of sides. So then you do 5 and 2.5. Now, why did I bring up all 3 ratios? Well, 10 over 5, isn't that just 2 over 1? 10 over 5 reduces to 2. If 7 over 3.5 also reduces to the same number, and 5 over 2.5 also reduces to the same number, then you are good. It checks out. All 3 sets of sides are proportional to each other, and everything works out. So even though we didn't have any angles, we didn't need any angles. We are just going to go with it, and we are going to call it the Side-Side-Side Similarity Theorem. Now again, don't forget, you've got to put that mark at the end. If you don't, then how do I know that we're talking about similarity and not congruence? There is a difference. We have to make sure we put that mark down there. Okay, so in this case, the corresponding sides were all proportional. It didn't say 2 of them, it said all of them. We didn't have an angle in between, so we had to test all 3, and we did. It checked here, and here, and here to the same number. All right, before we go, I wanted to talk about 2 examples of things that are not similar, because it's important that you recognize not everything is going to be similar to everything else. And we need to explain how we know. All right, we look over here, and we have a 3 matching up with a 2. So we got 3 over 2. Then we go over here, we have an 8 matching up with a 6. So we go 8 over 6. Now, because there are only 2 sets that need compared, we could really just put them equal to each other. Cross multiply. 3 times 6, 18. 8 times 2, 16. So 18 equals 16. Wait a second. That doesn't work. Now, some people don't like doing it in that order. Some people like writing 3 over 8 and 2 over 6. It's going to come out the same way. It is not going to work. Now, it did say explain how you know. Well, the sides are not proportional. I set up a proportion. It didn't make sense. 3 over 2 is not the same as 8 over 6, so it does not check out. All right, the last example of the day. Explain how we know that this is not 2 similar triangles, and they look really similar. It is so tempting to look at this and say, well, wait a second, we have matching proportional sides here and here versus here and here. Well, that would work with 2 that match up and are proportional as long as the angle in between matches. Then we would have side-angle side similarity. So let's go through and let's test out what's going on. Well, in an isosceles triangle, the base angles are the same. So if we have a 73 there, that means we also have a 73 there. That's not the right symbol, my bad. We also have a 73 there. So then if you add up 73 and 73, you get 146. Now, since triangles have to add up to 180, you could use that number to see what would be left. And what would be left would be whatever 180 minus 146 is, and that would not be 33, it would be 34. So these triangles were so close to being similar, but they're not. because the rule says right off the bat, this is the very first thing we wrote. In similar triangles, the angles have to be congruent. So if the angles are not congruent, then that means the two triangles are not similar. So even though they were close, close does not count. All right. I hope that helped you out. Thanks a lot for watching. I'll see you next time.